Okay, good afternoon, everyone. After a little bit of difficulties with the network that I'm on, I was able to get Twitch to connect. So we'll go ahead and get started. Still waiting for a few people to connect to this session. So I'll do a little bit of preface stuff initially. So this session today is about using and consuming Kubernetes. More so from a user perspective and in terms of running workloads, as opposed to some of my previous sessions, which have been focused more on the infrastructure space. So you can watch the screen as I go through, and if you want to follow along in the Twitch, if you look below, there's a link to GitHub, which has all the steps. So you'll want to go to the CNA folder. And in there, there's a markdown file for CNA Week 3. And that has all the steps I'll be following today. Now, there's more content than I can get through in a single hour. So we're going to try to work our way through it and get as far as I can, and then anything left over will be for another session. So any questions at all, just drop a message in the chat room, or if you have any comments or anything like that. It's better if the session is more interactive, so don't hesitate to drop a line. With that, I'll go ahead and make a start. The first thing, I guess, to talk about is that Kubernetes is effectively a platform for running workloads. And to be specific, what most people use it for is a platform to run container workloads. And what I mean by that is that you have one or more machines that you can connect to and schedule your workloads to run. And you can tell it how you want those workloads. So in the Kubernetes world, you've got what effectively is a cluster. And the cluster is made of multiple elements. You have a master node, which coordinates all the nodes in the cluster. You can have multiple master nodes to distribute the master services. And then you have the worker nodes where the containers are actually scheduled. So any workload that you run within Kubernetes is run on the worker node. So through these steps, we're going to be running these container workloads, and I'll show you some of the most basic commands to use so that you can kind of go ahead and get started. And hopefully that provides you a platform of knowledge that you can kind of build upon to investigate more specific scenarios. So I guess the first thing to talk about and the easiest concept to look at is namespacing. So many people will be familiar with the concept of namespacing, in particular if you work a lot with containers. Effectively, a namespace is just a location where you can start carving up resources. So for instance, on a file system, you've got folders which provide an effective namespace, and in one folder you can have one resource which could be a file, and in another folder you have another resource which could be another file. So why this is important in the Kubernetes land, if you have a cluster and you want to associate workloads and isolate it to some degree from one, like say maybe you have different teams of application developers or people using the cluster, you can have one context for one team and another context for another team. So let's go ahead and get started, and I'll provide some tangible items to kind of map that description. So let me switch back. So in my environment, I have a Kubernetes setup, and your usual command for working with Kubernetes is, at least from a client perspective, is kubectl. And from kubectl, you can do pretty much everything. So first thing I can do is I can tell it to use get, and get is going to retrieve information about the Kubernetes environment. And so in this case, I tell it to get information about the nodes, computers that are running this stuff. And in here, it gives me some information such as the name of the node, its status, role, age, and version. So I'm running Kubernetes 1.95. And if you want to get more detail, you can use different things like kubectl get nodes, and then there's an output flag, -O, and you can have different options. One option here is wide, so this means I get more columns. So I can see, like, for instance, like, what is the external IP address of the node, what version of the Linux operating system is it running, what's the Docker, etc. And you could even, if you wanted to look deep down, look into the information about a particular item, in this case a node, you can use the describe command. And so I can grab this, and I can say describe node, and I put it here. And it will show me more in-depth information about that particular node. So like I said, kubectl you can use for a lot of stuff. Just use kubectl by itself, and you can see all the different commands. It's basically your CRUD style operations. So create, update, delete, get information about these sorts of things. So going back to namespacing, like I said, we can create context to run. So for instance, like if I have a set of applications and I run them on Kubernetes, and I can use a command called kubectl get pods, and that will show me all the containers that are running. Now, I haven't started anything, so there's nothing there, but if you imagine over time, I may have a load of workloads there, and I don't want to get a view of this other team's workloads. I just want a view of my own. So this means I can create a namespace. So if I go kubectl create namespace testing, oh, well, I've already had one, so let me get rid of that. So if I go ahead and I create that namespace, whoops, let me just create a different one. Looks like I got some stuff left over from when I set up this class originally. So I can call it, let's see, test app. Oops, should be all lowercase. Okay, so if I tell kubectl get namespace, or for short I can do ns, it will show me all the namespaces. So a couple key things here. There is a default namespace, which is, as you imagine, the one that you're using by default. So any pods that are provisioned in that namespace will show up under there. You can see we now have a new namespace called test app that we created, and so we can start to use that. So what I'm going to do is I'm going to run a container. And in Kubernetes land, whenever you run a container, it creates a context called a pod. And a pod is, I guess if you could think about it as the smallest context for running workloads. So whenever you manipulate a workload, you're manipulating the context of the pod. And you can have one or more containers in a pod. So for instance, if you wanted to scale out a pod, it would scale out all those containers in the same manner. This is important to note because maybe the first order of thinking is when you create a pod to take, like if you got a 3-tier web app, to put the web front end and the application server and the database backend server all in a single pod. But if you have the same replication policy for that pod, it'll replicate all those items the same way. And you may not necessarily want your database server being replicated the same way that you are using for your web front end. So a common scenario that people do is roughly break out a pod to a container. And there may be, most pods will be like 1 or 2 containers. So you've got your actual workload container, and then you may have what's called like a sidecar container, which is like a helper container to do various things, which I may talk about a little bit later. So here we have our test app, and we're going to run a container, and so it's going to create a pod. So you have a couple of different ways to run your workloads. So you can do like a run command, so kubectl run, or you can create a definition file and tell Kubernetes to run that definition file. So we're going to do the first way, which is just a run command. So we'll specify the namespace that we want to use, in this case test app. and then we're going to run nginx, and we're going to tell it what image to run for nginx, which will be the nginx image. So it's created my pod. So if I do kubectl get pods, I'll notice that actually there's nothing there. So if you remember those different namespaces, there was that default namespace. So that's the namespace that I'm actually in right now still. So if I want to see the pod in the test app namespace, I have to tell it. There's a couple ways to do that. If it's a one-time thing, then in the command line we can specify the namespace we want to do. So kubectl get pods namespace equals test app. And there we go. So I've got the listing of the pod here. Now, if you you can change your namespace so that every command that you run is in a certain namespace, and you don't have to specify that namespace flag every time. So let me clean up after myself. Oops, helps the time. Okay. So the next thing to do is to talk about pods in a little bit more detail. So as I mentioned, so pods are groups of containers along with some associated metadata. So the metadata basically tells Kubernetes how this pod should be run. So we're going to dive into that a little bit. And so if I go kubectl run nginx, oops, and I list my pod. So I've got my nginx pod there. If you remember, I can do that -o for output flag and specify wide. And I'm going to get some more information, such as the IP address. So what I can do is I can, now that I have the IP address, I can access that. So nginx is just basically a web server. And if I do curl here, I've got the response. So curl is basically just a text way of getting a web page, HTML from a location. So essentially, I've got like the welcome web page. So if I point at my browser here, it would show me the HTML for this. Okay, so we have a pod that we've created. So the other way of creating the same pod would be via a manifest file. So let me get rid of this. And we'll create our manifest file. So as I mentioned, all this stuff is on GitHub under CNA week 3. And in there you can see the specification. So I'm going to create a text file with an extension of .yaml and place the details for how I want the nginx pod to run. So let me go over and grab that stuff. Okay, so I've just created a file called simpleapp.yaml. And in here I have a few bits and pieces of information. So the first thing is I have the API version. So this tells us what version of the Kubernetes API that we're using. So for these YAML definitions, if your version of Kubernetes is significantly older, younger than mine, you may have to change this version number. Easiest thing to do is just go to the Kubernetes documentation site. And so for in this case, we're creating a definition for a pod. So on the documentation site, you go to pod. And then on the top right-hand corner, there's a version drop-down. So you just select the version of Kubernetes that you're using there. And in the documentation, they'll give you an example of the YAML definition for that resource. So you can see what version of the API to put in here. The other thing is I've got kind. So this tells Kubernetes what I'm creating. So in this case, a pod. And then, as I mentioned before, there's some metadata that I'm associating to this. And then I tell it the spec. So in this case, I'm creating some containers. And I'm actually just creating one container here. And for this example, Nginx, I can probably actually get away with having this even a bit more minimal. So I'm just going to delete some of these lines here. All right. So you can see there's not a great deal of information here just to get a minimal pod running. So now how I tell Kubernetes to run this pod is I use my kubectl command, and then I use the apply command. I use the -f flag to specify a file, and then I tell it the file. So now if I do kubectl get pods, I see that it's starting to create this container. So I have the name of the container. Ready means that how many containers are actually running. In this case, we've declared that we want one container to, or one instance of the pod to run. And right now we have 0. The status is that it's actually creating the container. So if I go get pods again, I can see that the status is now changed to running. And if I do -o wide, I can get the IP address. So if I curl this IP address, I should get the Nginx, which I do. And now if I want to clean up after myself, instead of that apply command, I can do a delete. So kubectl delete -f, and then I just hand the file back again. So this is going to go ahead and delete everything that was created from the file. So now we can start to think of more interesting things that we want to do with these containers. And one of the things may be to verify that the container is up and running or it's healthy, different things like that. If it's not healthy, we can do different things like we can restart the container, or at least other systems that rely on this can get some information about the health. So we're going to create a pod definition like we did, but we're going to specify some more metadata so that we can do this health check. So go back. Okay, so I've created this file, and you'll see we got all the same information as before. And so one of the things is that if we skip down a little bit, you'll see something new. This is called the Liveness Probe. And here we can specify how to report the health information. So for a web server, typically you'll, at least from a basic level, want to make sure that you're actually getting stuff served by the web server. So in this case, we've created a probe called the HTTP GET. So this will go and get from a certain path information. And so the path is set to /, so it's basically if you go to the site and specify nothing in terms of the path, we're just going to get the index there. And we're specifying the port. So this is HTTP, so default port 80. And so this is just going to go and make sure it can get some content. If it doesn't get content, like if it gets like a 404 file not found, something like that, then it's going to fail the liveness probe. And I can specify some detail about the probe, such as the initial delay. So, you know, we saw earlier that there was a little bit of a startup time for creating that container, that pod. So we don't want it to test right away, or else it'll fail right away. So we're going to delay it by 5 seconds. There's also some thresholds, like how many times should you fail before you fail completely, and what is the timeout if things are taking a long time. If this area is really interesting to you, there's actually a whole load of other options that you can do to have a more feature-complete testing. Hopefully this will give you an idea. So I'm going to write this, and now I'm going to deploy it. So just that kubectl apply -f, and I tell it the file that I want to run. Okay. And now, if I do kubectl get pods, I can see it there. And if I want to find out more information about it, I can use the describe command that I used earlier. So I'll just grab this name here. And so I'll see all sorts of information about this pod. And what's particularly interesting here is the information about the liveness. So here I've got detail about the configuration for this liveness, such as what it's doing, which is an HTTP GET, where it's going to, and the configuration settings that I've created. And here I'll see below the details about the running nature of this pod. And then I've got the history. So on my screen, my font size is a little bit too big, so I'm going to minimize this a little bit to change the ordering a little bit. Just bear with me here. The font's going to be a little bit smaller, but hopefully still readable. I'll run that command again. Okay, so here you can see the history. So we scheduled the container, we did our mount, we pulled the image, we successfully pulled the image, we created the container, we started the container. So if you want to see some basic information about the life cycle of a pod, you can use the describe command in order to get that information. Okay, so I'm going to change this a little bit to kind of break it. So let me get rid of my current definition. And let's modify that file. And in the path, I'm going to create a specification for a direct place for it to check, but this doesn't actually exist. So it's going to fail this probe. Oops. What's going on here? Ah, I've got typo. Okay, so just give this a couple seconds for it to run. All right, so now let's go ahead and take another look at that describe. And as you, so we got the liveness details up here, and then in the events, we see an event which says, warning, liveness probe failed. HTTP probe failed with status code 404. So this means that the location that we went to, which is this one, there was nothing there. The web server gave it a 404 error code. And then you can see kind of like how many times it's done this over how many seconds. So this will actually go up to 3 and then it will completely stop. So as you can imagine, it's quite powerful. If you start deploying pods that have dependencies for other pods, you can use these probes and health checks in order to make sure things are working good before you start serving your users. So let's go ahead and clean up after myself. Okay. So the next thing that I'll talk about is that, so for a lot of container workloads, the storage of them will be ephemeral, meaning that they're just processing data. They're not really storing anything to keep around. So for instance, like a web server may just be giving out HTML pages. It won't be receiving and storing any information there locally. Typically, it would send that stuff off to an app server or database server to do something with that. So you don't really have to worry about making sure that that storage hangs around. But other times there will be reasons to create storage for containers. So like if you're running a database or you've got some files that need to be changed over the running of the pod, you'll need to figure out a way to create that persistent storage. So within the pod definition, we can tell it a persistent volume. And a volume can come from anywhere. It can come from the local machine, as in the worker node that it's running on. You can map that over, or you can provide it something from the network, like via NFS or some other service like Gluster. So let's give this a go. And I'll grab my Kubernetes definition. So we've got a few new things here. So we're still making pods. And in the pod definition for spec, we're now defining something new. So we're creating a volume, and we're giving it a name. The other interesting thing is that the volume is using a host path, meaning a location on the Kubernetes worker, in this case var log. So our Kubernetes workers are of course Linux, and they have a folder structure where the log files are kept. So this means that we're going to create this volume, and it's going to have access to the local logs in that machine. So we're still using our Nginx image, but now within that container, we specify a mount. And the mount path is the location inside the container where this will be available. So that var log won't be var log in the container, it will be /data. And then we're specifying the name. So as you saw earlier, we created the name for that volume. Everything else is more or less equal. In fact, don't even need the support information. It's not needed. This is all we need. So I'll save that, and we'll go ahead and apply this. And it's created our Nginx pod. So we're going to wait a little bit for this to execute to make sure it's running. Okay, and it's up. For the purpose of this demo, I'm going to show a command where we can get local console access to the container that was specified in that pod so that we can show the directory structure. So kubectl has a command option called exec. And in exec, we can tell it for what pod we want to do something in. So for instance, in Nginx storage, which is the name of the pod that we just created, we're going to run a command, in this case bash, and we want to tell it, we want this to be interactive. So now we have the command line access on that container within that pod. And so if you remember, we created a volume mount called data. So here we've got, we're in root, you can see that there's a data volume, or at least a folder. And if we go in there, we can see all the files that are on the underlying Kubernetes worker. So this provides us a way for having persistent access to storage, even after the Kubernetes pod is deleted or recreated and all that sort of stuff. So I'm going to exit out here and clean up after myself. On the GitHub page, I've included a list of handy commands for working with pods. I won't go into all of them now, but they're there for your reference. So this means like how to execute a command inside a pod, how to check the logs for a pod, how to copy files from one location, like our client location, up into a pod, these sorts of things. So it's quite handy. Just take a look in the pod section for those useful commands. The next thing that I want to talk about, and is actually an extremely important concept within Kubernetes, is the notion of labels, annotations, and selectors. So a way to think about this is a label is like a tag. So if you have a resource, any resource mostly, such as like a pod, you can tag it. And then if you later on do an operation and you want it to target all the resources that have that tag, you can define a selector. And so, for instance, like a label could be if you have a collection of pods and they all form a particular application, you can label them with the application name. And then in the future, if you want to change the behavior, instead of having to specify all those pods manually, like hand by hand, you can just tell the behavior change to target everything with that particular label by defining a selector. So let's go ahead and take a look at that. So I'm going to create my YAML definition. And in here, you'll notice I've got some new things. So under the metadata section, I've got a label, or I've actually got a couple labels. So in here, I've created like an arbitrary thing. So like stage, as in what part of the software development lifecycle does this pod exist in? Like, is it in the development life stage, or is it in the testing stage, or is it in the prod stage? So in here, I've got prod. And the version, so this is like the first version, so I'll just call it version 1. So labels are like key value stores. So the key is stage and version, and the values are prod and 1. And so you can have one or more labels. The other thing that I mentioned are annotations. So annotations, an easy way to think about this would just be like notes. So for instance, if you're not going to be automating against the data of a note, as in like if you're not going to be using selectors to find labels, it's just you want to have some notes so that when people look up this item later on, they can see some information about it. It could be anything. So in this case, I've created an annotation called reasons, and the description here I've put in pod showcase. So if you're running in a organization, you can put organizational data. So this could be like stuff like who requested it and why they requested it and all that sort of stuff. And let's get rid of this junk. So let me go ahead and run this. And now, let's see, we could make this more interesting. kubectl run Selectors. Okay, so I've created two pods. So the first one via that YAML spec, and then I've run another pod, which is effectively just CentOS. And so now if I go kubectl get pods, I've got those there. And if I do kubectl get pods show labels, I can see the labels associated to that. So for instance, if you go down to the Nginx label, I can see stage is equal to prod and version is equal to 1. And now if I just want to get all the pods that are in stage prod, I can do kubectl get pods selector equals, and I'll do stage is equal to prod. So that just returns to me all the pods. In this case, it's just that one pod, Nginx label. So you can use selectors in your definition file. So like later on, you do like ReplicaSets and things like that. You can specify selectors there. Or if you're doing troubleshooting information via the kubectl command and you want to grab up all the pods that meet a certain label, you can use the selector in the command. So let me clean up after myself. Oops. Okay. So the next thing I'm going to talk about is ReplicaSets. ReplicaSets is a way to duplicate your pods. So you may have reasons to duplicate pods. This could be maybe you need multiple pods to handle all the traffic that's coming in, or maybe you need multiple pods to handle availability concerns. So like for instance, if one pod falls over, you still got 2 or 3 or more pods that are up and running. Or maybe you want to compute something and you want that compute to be distributed across a number of pods. So these are some of the reasons for replicating pods, and you use a replica set to control that. So let's take a look at a replica set. Okay, so there's a couple of things that have changed here. Number one, the kind is no longer a pod, it's now a replica set. And the other thing is that a replica set has its own API version. So in my case, I need to target apps/v1 beta 2. If your version of Kubernetes, like I said, is significantly different from mine, just want to take a look on the Kubernetes documentation page to see what version is specified. The other things that are interesting here is under spec. So in this case, I specified replicas. And this is where I can say, like, how many of these pods do I want to run? And then I have my old section here for containers. So this is the containers that I'm running in the pod. So let me quit out of here and run this. So now you'll notice that it's running 3 pods, or at least it's starting to run them. And there you are. So some of the interesting things here is that we'll cover a little bit later service discovery, or actually really quite soon. But this is a good way to couple replicating pods with service discovery so that you can cluster things. One of the other things I wanted to show is like we can modify this replica set to decrease it or increase it. So for instance, kubectl scale replicas equals to 5, and we're going to give it a target, in this case a replica set of Nginx. Oops, what did I do? Oh, I've typoed. Okay, so now if I go back and get pods, I've got 5. So people will talk about Kubernetes as a declarative platform. So this means that you tell it the state that you want the platform to exist in, and then Kubernetes monitors the environment, and if it's not looking like that state, it makes it that state. So for instance, it saw that for the replica set, we've declared that we want it to be 5 pods, and there were only 3 pods running, so then it created enough pods to fulfill that definition. This is different from imperative, where we issue one command at a time to modify the state over time. So if something doesn't exist the way that we want, we have to keep issuing commands till we get it into that state. So let me go ahead and clean up after my... Actually... I'll leave this running because this is actually helpful for the next section. So I'm going to cover service discovery. Now we've only got 13 minutes left. I don't think I'm going to cover the whole thing in that time frame. What we're going to try to get as far as we can. So service discovery is essentially about 2 things. So the first off, we have to realize the limitations of containers, meaning that containers are quite ephemeral, as we talked about from a storage perspective. This also extends to the network side. So a container has an IP address, but every time there's a lot of different events that may happen through the life cycle of a container where the IP address may change. So if the container stopped, restarted, deleted, recreated, all that sort of stuff. This means that we can't really rely on that IP address pointing to that container all the time. So we need a stable way, like to specifically state that this container gets this IP address. The other thing is that because IP addressing is quite variable, if we use our traditional DNS tools, people like the DNS clients oftentimes will cache the results of a DNS query, meaning that we don't have a reliable way for always getting the network address of that container. So in Kubernetes, we get 2 things. Number 1, it can allocate IP addresses to pods and containers, and also provide DNS services so that it has the intelligence to make sure that the resolution for that domain name always points to an IP address that can reach that container. So that's a lot to talk about. Let me kind of start showing examples. So what I need to do here is to create a concept of a service. So this, as a replica set is a kind, so is a service. So let's go ahead and create a definition for that service. Okay, and now let's take a closer look. Oops. So API version is changed and kind is changed. So kind is service, and for that definition in Kubernetes, I have to adhere to a certain version, in this case version 1. I've called it Nginx service, and I've given it a selector. So if you call back to the label, so in my replica set I have a label called Nginx, and in here I'm targeting all pods that have that label. And so what I'm going to do here is I'm going to create a clustered IP address across all those pods. And if you remember, we've got 5 pods running. So let's go ahead and apply this. I'm missing an E. Yep. I'm missing a Y too. Okay. So I've created a service, so kubectl get service. And it shows me all the services that are created. So there's a Kubernetes one by default, but more interestingly is the next one, the service called Nginx service. So it's telling me the type, which is a clustered IP address, and then it's giving me the actual cluster IP. So if we go and we can get actually even more information about this. So if I do kubectl describe service, and then I put in the service name, I can see some interesting things. So I can see, of course, the information I specified as well as the IP address, and then I also have the endpoints. So the endpoints is all the pods that it's clustering. So if I go curl actually, first I'm going to do it this way. So I'm going to run a pod. Let's check things here. Okay, I'm going to run a pod, and I'm going to jump into its local command line, and from there I'm going to try to access this session. So I'm going to do my kubectl. And I'm going to do the run -I because I want this interactive, and I specify I want a TTY, so terminal. Give it the name of the pod that I want to run, and I'm going to give it the image, which is CentOS. And just going to specify a couple of required bits and pieces here. Restart equal never. Cinch. So this should drop us into the bash prompt. Okay, so I'm now in that CentOS pod. So let's do some things here. So for instance, curl Nginx service. Let's see what this gives us. 80. Oops. I think in my definition I have some old data. We'll modify that in a moment. Let me just test this one last thing. Okay, so let's back some of these things out first. I have an error in my YAML definition. Oops. Here, this target port, we don't need this. So get rid of that. Cool. And now we'll apply that. Okay, so now let's go back up into our CentOS container. Oh, we haven't deployed that. Okay. I'll need to clear that up in a moment, but for the sake of getting to the we just got a couple minutes left. Oops. Okay, let's try this again. Nginx service. There we go. So, two things here. Number one, I queried the name of the service. So this is using the inbuilt Kubernetes DNS. And it's up to date with the IP address for the cluster. And so if we do, instead of using here, and we do curl, that cluster IP address that we got before, it's the same thing. So this means that across those 5 pods, you can just point to a single IP address and it will go to any pod that's running. And also, we can use DNS. So if the cluster IP address needs to change in the future, we can just point to Nginx service and it'll handle the DNS resolution there. So there's actually a lot more to cover in the service discovery, such as load balancing and all that sort of stuff. But we're now at the top of the hour, so we'll have to wrap up. Hopefully this kind of whets your appetite. I'd say we've got through about 45% of the content. That should give you a good starting base for Kubernetes. In a future session, we'll cover off the rest of service discovery, and we'll start to get into different ways that you can run pods, such as DaemonSets, jobs, singletons, StatefulSets, and then we'll get into the concept of deployments. So thanks for attending this week's session, and always feel free to drop me a line with any comments or questions. Thanks very much.